The homework for this coming Wednesday night, there are 3 sections homework due this coming 26, 27, 31. So there are 3 homework sessions this coming Wednesday night due. If you have any questions, please do ask me any questions. You can ask me either via online, via the emails. Make sure you send it to me, and I know I will reply back to you. And the other thing I want to point out also that this coming Wednesday, I don't have any Zoom classes due to some personal reasons. So you don't have my class on Wednesday. And then do not forget on following Monday is Labor Day weekend. So we don't have class. So actually I won't see you guys till like 10 days. So today and then the next time we see you is next Wednesday, not this coming Wednesday. So like 10 days from now. So make sure you guys, so do communicate with me via email. That will be the best way. If you have any questions, email me with any questions that you have. That will be really, really awesome to do it. So so anyone have any questions for me with your homework? You got 3 sections homework due this coming Wednesday. 26, 27, and 31. I got, yep, anyone? Just, you can put in the chat room, you can mute yourself. I got one of the homework questions that one student asked me about how do you write a composite function. So I think it's given us like 1 over x squared. This is one of the example. I think it's x minus 3, something like this. This is the function of some f dot g or f, something like that. This is 2.6. The question is asking you to, what is the domain for this? Okay, so in order for us to figure out a domain here, you cannot have this equals to 0. So in this case, you will get x equals to 0. And in this case, x equals to 3. So that means your domain in this case is all real numbers where x cannot be 0 and x cannot be 3. So this is the answer you will get. This is correct. But how do you write this in an interval notation? So if you think about this, so it's every number you can have, you cannot have 0 and you cannot have 3. So that means that your interval notation will have 3 pieces. One goes from 0 to the left. The other one is in the middle. And then the other one is from 3 going to the right. So that means in order for you to write your domain here, your answer should be from -infinity to 0. This is the first one. Union 0 to 3, which is the middle one. And then 3 to infinity, which is the last one here. So make sure you guys know what to do with this kind of questions here. I forgot what, I know it's from 2.6, but I don't know what number is it. So this is how you answer this in your online homework on 2.6. Okay. 3.1. I know it's any graphing on 3.1. I'm just double check because some of you might not even be, because it's a parabola. Some of you, they might want you to graph it out, and I'll show you how you graph it. So it looks like everyone has a graph here. All right, so this is the graphing piece then. Okay. So let's say you want to graph this. This is 3.1. I don't know how many of you did. There are more graphing pieces here. So so how do you graph a quadratic function? So first thing you need to do is you have to select this. This is your parabola, and it's a parabola open upward or downward. So this is the one that so make sure you first thing you select is that one first. And then let's say you find the vertex here. This is x squared minus 3. So so I'm showing you how to graph this equation here. So we have this is 2.1. The function is given as x squared minus 3. So we know this is a parabola. Does anyone know what is this minus 3 means in that function even? Anyone? Anyone know transformation? What's minus 3 stands for? It's a parabola going where? Anyone?
Going 3 to the right.
Nope, not move to the right. That's wrong. Left, right, up or down? Which one? So this means you're going down 3. You're going down 3. So it's a parabola that goes down to -3. So this is your graph looks like. Can someone tell me what is your vertex? What is a vertex? No one chatting? No one? You guys are quiet? Anyone? What's your vertex? Right here, this is your vertex, right? What's your vertex?
-3.
0, -3. And what is the axis of symmetry? That's the line I draw.
Is 3.
X equals to your vertex, your X value, which is 0, right? So now I'm going to teach you how to draw this graph in your WebAssign here. So we know it's going to be parabola with the vertex. Vertex come first, so 0, -3. Now, unfortunately, your WebAssign, you need another point. So what you do here is you just need to simply plug in another number. So let's say you can plug x is 1. Plug it into here. So you get 1 squared minus 3. This is actually is -2. So your coordinates is 1, -2. So what you need to here, what you do in your WebAssign here is you actually have to give me another point. And that point, you plug x is 1 or 2 or 3, whatever number you want, except 0, because we use it here. So 1 squared minus 3 is -2. So you click on here, and they will automatically draw you a parabola. So in order for you to do your WebAssign to draw a parabola, make sure you need 2 points. One of them must be your vertex, and the other one is any points on the parabola. And the vertex is 0 through -3. And don't forget, when you type in your axis of symmetry, make sure it's x equals to 0. So if you just put 0, they will mark you wrong. X-intercept. So how do you find your x-intercept is you set this equation equals to 0. So in order for you to find your x-intercept, you set x squared minus 3 equals to 0, and you solve for x. So I move the 3 over. So you got x squared equals to 3, and then you take the square root of it. Now, every time you take a square of it, you need what sign on it? What sign you need when you put a square root on it? You need the symbol of plus and minuses. So your x-intercept is square -√3 and +√3. So that's how you enter this. It must be in coordinates because your x-intercept is a coordinates. So they ask you for the smaller one. So which one of this is the smaller one? Positive or -√3? So definitely the negative is a smaller one, right? So that means your answer in this case will be negative. Don't forget the square root is on the calculator pad. So √3 here with a 0. They want the small x value first, then they want the big one, which is the square root of 3 and 0. Don't forget your x-intercept, your y value is always 0. You guys all right here? How you draw your graph and figure all this in your 3.1 homework? Anyone have any questions here before we start with 3.2 and 3.3? Anyone? Questions? And this is the same thing. You just need to do the same thing. All right. If you do, please send me an email so I will help you with it. So today we'll talk about 3.2 and 3.3. As those who came in late, don't forget that we don't have class. I don't have class on Wednesday because I have some personal stuff going on. So class is canceled for me on this Wednesday. So I won't see you. And then Monday is a holiday. It's a Labor Day weekend. So I also will not see you. So the only time when you come back will be the next Wednesday, which is like 10 days from today. So you do have 3 homework due this Wednesday night. 26, 27, 31, and then 2 homework due on that following Wednesday, 3-2 and 3-3. So we're going to talk about 3-2 here. So what we're going to talk in this case is we're going to mention about what we call as a polynomial with the higher degree. So last time we did x squared. So this time we will do higher than x squared. So we do x cubed, x4, x5, x6 to the power. So your polynomials is going to be really, really a bit more higher than you know, instead of just x squared in this case. Sorry, this is online homework. Okay, so I will save for this so you can. So what we're going to talk about here in 3.2 is every time when you draw a graph in a higher polynomial like x cubed, x4, x5, your graph has to be continuous and the turning point has to be smooth. So no breaks. Oh, wait for a minute. I need to. Oh, I recorded. Do I record this one? Yeah, I did. So it's continuous means that no breaks. So that means when you draw the parabola, when you draw a x cubed, you cannot do like this and then a little like this and then this. So this is called not continuous, means it has breaks and holes. So continuous means you can draw this whole graph in one stroke, you know, like without leaving your pencil or pen. If you draw it with a pencil or pen. And then the turning points has to be smooth and round. That means that it's like a parabola. It has like a vertex. It has to smooth like this. You cannot be zigzagging, or you cannot be like exactly like a cut off like a square type or rectangle type. So it cannot be like this. So every time when you draw a turning point, we call this as a turning point or your vertex, this has to be a smooth turning point like this. Okay. So, and you cannot have all these little holes and little gaps in between. So this is what we call, so when you draw it, it should look something like this. Okay. So this is going to be smooth turning point here. So it's not going to be like, it's going to be like a U-V or like a U-turn or like upside down view. Okay. So what happens to your graph looks like? So as you know that when you talk about xn, when n in this case is even, like 2, 4, 6, 8. So we did the x squared. So x squared is a parabola where the axis of symmetry is on the y-axis. So, and they are like, you know, they are kind of a reflection on the y-axis here. So this is x squared looks like, the graph of x squared. So what happens if I increase this to power 4, because this is even? So what happened is that your graph will look like x squared, but over here a bit more flat. Okay. So this is a bit more flat. So this is what happens when you have x to the 4. And what happens when you have x to the 6? So the more higher power you get, you will get a tad bit of narrow, and then this one is even flatter than x4. So this one is even x6. This one is even flatter. So this is what happens when you get just the x squared, the even power, x squared, x4, x6, x8, and so on. So you find out the power when you touch here is flat, and the more higher power you use, the more flatter you get. So, but what happens when it is, so what we call this graph, it is an even graph. So every time when you have an even graph, it is symmetrical with respect to the y-axis. Symmetry with the y-axis. That means that your y-axis is kind of like a axis of symmetry. So when you fold it, it was, you know, reflections on it. So what happens when you increase for odd, for x cubed and so on? So when you have x cubed, the graph of x cubed looks like you go up here and then you go cross down at 0, 0. Again, it crosses at 0, 0 here. So this is the graph of x cubed. Okay. So what happens when you make it to x5? Again, this is all must be odd here. So it looks like x cubed, but it will become flatter at the origin 0, 0. So this is the x to the 5th point. So this is actually flat over there. And then what happens if you go up to x7? It will be even flatter. than the x5. So this is x7. So this is even flatter in this case. So for this kind of odd functions here, is always symmetry with the origin. So what is the meaning when I say symmetry with the origin? It means that it's symmetry right on the origin. So when you kind of like flip this on the origin, sometimes I say both x and y axis, but usually it's not the correct terminology. But so if you take this this graph and x cubed, and you flip this on the x-axis, you will get this graph. And then when you flip the green graph again on the y-axis, you will get back the same old original graph of this. So this is what we call as symmetry with the origin. Means if you flip this on the x and y axis, x plus an x or y and y or x, doesn't matter which one comes first, you will get yourself the same graph in this case. So this is what we call as the even and odd for your polynomial graphs. And then we talk about leading coefficient test, or sometimes we call it as your end behavior. So that we have names for it. Sometimes we call it leading coefficient. Sometimes we call it end behavior. What is leading coefficient test or end behavior test that I mentioned here is this. This is the leading coefficient test. So that means what happens to the graph on the left side and the right side of it. So you notice that if you have an even graph, this is an even graph, and your leading coefficient is positive, they are positive here, you've noticed that all your graph, both your endpoint left and right goes to up, both up. So so what happens is that on the left, it goes up, and on the right, it also goes up. So this is what happens when you have a positive. Now, what happens if you change it to become negative? That means negative x squared or negative x4 or negative x6. So that means your graph will go downwards. So so when you have a negative leading coefficient for even graph, you will go down on left side, and you also will go down on the right side. So you will go down on both ends. Okay, this is what happens when you have a even, if your leading coefficient is plus and minus. So for this, I will say if n is even, if they are positive, this will goes up on the left, and also it goes up on the right. But for the leading coefficient is negative, it was down on the left and down on the right. Okay, so this is the when n is even. Now let's talk about what happens when n is odd. So when n is odd, which is this one, and the leading coefficient, they are all positive, you find out that on the left side, it goes down. On the right side, it goes up. Okay. And what happens if you have a negative in front of your leading coefficient, but it is odd? Then you switch around. That means that you will be going up on the right, on the left, sorry, and down on the right. So for these cases, the leading coefficient when n is odd, when they are positive, this is where you go down on the left. What happens? Down on the left and up on the right. So down on one side, up on, so let me see. I got reverse. Yep, sorry, it's reverse. Sorry. So you go down on this side and then go up. That is what happens. And then when you have that, you go up on the left. Oh my God. And down on the right. So you just move that around like this. Okay. So make sure you, so that is what happens. Why this is important is because if I just give you a graph, remember I simply draw a graph like this. Can someone tell me what power is this? Is this an even power or is that an odd power? If I show you a graph like this. Anyone? Even or odd powers if I give you this graph?
Is it up?
It's odd power. Yes, that's correct. And is the leading coefficient is positive or negative? Since it goes down on the left and go up on the right, so your leading coefficient is what? They're all positive. So that means your answer in this case, your x here is odd, either 3 or 5 or 7 or 9 is odd, and the leading coefficient is positive. That means when you write this x to the highest power has to be plus because it goes down here and go up there. Okay, so that is how you figure out just by looking at graph. You can tell what is the power of it and what is the sign in front. Is that plus or minus? Okay. So the other thing we're talking about here is the zeros. Okay. So what are zeros? This is very, very important. Zero in this case is your what we call as your x-intercept, or sometimes called as a solution. Okay. So remember last time when you have x squared, how many answers do we have here for x if you solve for it? How many answers you have in this case when you solve for x? You guys should know this. How many answers you get? You factor this and you solve for it. How many x values you get? You got 2x value, right? So this is what happens to this theorem. We call that as your fundamental theorem of algebra. It says that if you have a power 2, you can get at most 2 answers. So when you have an x to the power of 4, how many answers can you have? You can have at most 4 answers. And when I say answer, means your x-intercepts, where you intercept and not x. So when I say at most, does anyone know what's the meaning when I say at most 2? Is that 2 or more or 2 or less? When I say at most 2. This will be 2 or less. That means you can have 0 answers, you can have 1 answer, you can have 2 answers, at most 2. And when I turn this to power 3, the highest, if this is x cubed, then you will have at most 3 answers. That means you can have 0, 1, 2, 3 answers. So it depends on your power. So if your degree, so if you have 4 degrees, so you can have up to 4 answers or 4 in x-intercept. And turning points. Turning point means that the vertex. How many turning points? You can have at most n-1 turning points. So that means that if you have like if you have this, how many turning points do we have here? You got 1 turning point, 2 turning points, 3 turning points, and 4 turning points. So we know this fellow is going to be x to the power of 5. Because since you got 4 turning points, so n-1 equals to 4. So n in this case is 5. So that means your power in this case will be 5. And it's going to be a positive 5. So the turning points tell us what is the power. So that means if you have power 5, you can have up to 4 turning points. If you have power 3, you will have up to 2 turning points. So this is mostly what power 3 looks like. You got 2 turning points in this case. So this is how we figure out the turning points. It's very, very important. Okay. Then we got all these names here. So this is something that I want you guys to know, and this is very important, especially for your first test. So where you have your power is n, you got n real zeros, and you got n-1 turning points, which is your vertex. Now, sometimes we have the word zeros. Sometimes we use the word solution, we use the word factor, we use the word x-intercept. So all these are the same. So if I ask you to find the 0, if I ask you to find the solution, the factor, or the x-intercept, they all means the same thing. So for example, in this case is if I give you this this x plus x squared, let's do x squared first. So if I give you this x squared plus 5x minus 4, let's say this is the function. And if I want you to find the zeros here, and how do you find the zeros here is you just need to set this equals to 0 and you factor it. Can someone tell me what is the factor for this? Anyone? Oh, sorry, wrong. Let's put this plus. Sorry, this is plus. My bad. This is plus. So what is a factor for this? X squared plus 5x plus 4. Anyone? Factor? Hello?
X plus 1, x plus 4.
Yep. Right, and then you solve for make them equals to 0, right? So x in this case is what? -1. X in this case is what? -4, right? So this is what I call as the zeros. This is also what I call as the solution. So if a question asking you for zeros or solution, this is what it looks like. But what happens if I want the question in x-intercept? What is the x-intercept for this case? So what you need to do is you just need to take these two numbers and put it in a coordinates form. -1, 0, -4, 0. So this is the x-intercept. It's the same thing. It's the same thing as I say. It's just the way that you write your answer is different. And what is the factor? If I say what, give me the factor for this, and the factor in this case is this: x plus 1 and x plus 4. This is what we call as your factor. And they're all the same thing. So that's why when you look at my notes, if I say x equals to a is a 0, then x equals to a is a solution. But if I want to write in the factor form, this a will change. So if it's positive, become -a. If it's a negative, it will become a +a. And then if I want an x-intercept, it's going to be in a graph and in the coordinates form, a0. And how do you find this? You solve it. They all means the same thing. You guys all right here with this? And when you guys do your homework and my test, make sure you read the question carefully. Sometimes your homework wants the 0 form, sometimes your homework wants the factor form, sometimes the homework wants the x-intercept form, or sometimes they want it 0 and factor, like combinations of those two. So the way that you write your answer, if you just give me, if I want a factor form and if you give me just -1 and -4, they will mark you wrong. Same thing with x-intercept. You give me -4, -4, they mark you wrong. They want it in this form or that form. So just be aware about it. That's what I'm going to point out to you. Okay. Next thing I want to talk about in this case is your repeated zeros. So what is meaning when you have a repeated zeros? This is 3.2. So when you have a repeated zeros is where you will take the factor of it and you have a power to it. So usually when you do the factor form, it's just power 1. So when you have x minus 2 or x plus 4, something that we just did, and then they are power 1. So so this k in this case can be power 2, power 3, power 4. So if your k in this case is odd, like power 1 that we have, then what happened is you will have, when you do your graph, it will cross. It will cross at A. So let's say that if you're gonna graph this, this is power 1. Let's say k is 1. So you got like x minus 3, for example. So it will cross at 3 either this way or that way. Either one of this way, it will cross. Depends on how your end behavior or your turning points looks like. But what happens if your k is because it's odd, so 3. Then you will still cross at 3, but in a cubic way. So you can do it this way, or you can do it either that way. Okay. And what happens if your k is 5? Again, it's odd. It will cross at 3 again, but this time it will go flatter. It will go flatter. So you go flatter here. And then if you have 7, even flat. Okay. So this is what happens when you have when k in this case is odd. What happens when your k is even, like 2, 4, 6, 8? Then your graph in this case will be touching it. You'll be touched at 8. So example in this case is when you have x minus 3 squared. So again, you will at 3 is your zeros. It will touch. Your touch can be either going upwards or going downwards. It depends again on your end behavior. So it's going up or down. But what happens when it is power 4? So it's still going to cross at 3, but in this case, the same thing as what you do in 3 and 5 here is this fellow will get flatter. And if you have a power 6, it's even flat. So this is what it means by when what we call as repeated zeros is your power is being repeated by your 0 is repeated by a power k here. So odd means you always cross. Even means it's touch. The more higher the power is, the more flatter it goes on your x-intercept. Okay. Anyone have any questions for me here with this repeated zeros? This is what we talk about, cross and touches, odd and even. Anyone? So I will do some examples here. So let's do some examples here. So let's talk about find the polynomials given us these zeros. So last time, remember, you give me zeros, right? I give you a polynomial, x squared plus 5x plus 4, and you give me your zeros. You factor this, and then you give me your zeros, right? Now I do the opposite. So in question 4, in the notes here, I give you the zeros is 0, -4, and -5. You have to give me the polynomial. So how do we do this kind of work is you write this in the factor form first. And how do you write this in the factor form? If I say x equals to 4, the factor form will be x minus 4. So can someone tell me what is the factor form for 0? Anyone? This and that. Suksa, what you get? Kelvin. What's the factor for 0? Anyone?
0.
No, don't forget. If it's x equals to 4, the factor form is x minus 4. So if I give you 0, it's just x. Because it's x minus 0, which is just x. And what is the factor form for minus 4? Henry? Avery? Gamal?
X plus 4.
This is x plus 4. So again, when I want you to write in a factor form, your sign has to be switched around. So if it's a -4, +4, put an x in front. How about -5? What's the factor form here? It will be
+5.
x plus 5. Don't forget the x. A lot of students give me +5. Okay, make sure you have x. So this is the factor form, but they want it in a polynomial. So what you need to do next here is you have to distribute this. So because we got 3 of this, last time when you got 2, you just FOIL this fellow out, right? And then you will get this. This will be your answer. Okay. So what you do here is, because we've got 3 of this, so what you do is I recommend you to FOIL this follow-up. So go ahead and FOIL those 2, 1 out. You should know this. So FOIL out. I want all of you to FOIL out. Yep. So FOIL this follow-out, and what you get? I'm gonna ask you guys now.
X squared plus 9x plus 20.
Plus what? 9x plus 20. Yep, that is correct. So 4 plus 5 is 9. 4 times 5 is 20. And what you do next is you have to multiply this with your x. Don't forget, you still have the first x that we did not do. So what you do now is you distribute. So what is your answer in this case?
X to the 3rd power plus 9x squared plus 20x.
That's correct. So this is your answer. But if you give me this answer in your test, I will take half a point off. This is all correct, but I still take half a point off. Does anyone here know why I take half a point off?
You can divide it by x.
Nope.
No.
Don't divide by x. Just the reason why that you get half a point off in your test is because this question wants us to write as a polynomial. So polynomial is right in the function. Polynomial functions, you should have a function inside. So you do need to give me f of x here. So a lot of students lose a half a point in your test is because they forget to give me f of x. Okay. So don't forget about that. So make sure you FOIL this out, and then at the end put f of x in there. So if I ask you for polynomial functions, so you give me f of x. If I ask you for an equation, you use y. So that's the difference between a function and equation. So when the question in your test or homework say, give me the polynomial function, use f of x or g of x or h of x, doesn't matter what letter you use. If I want to give me the equations, then you should use y equals to that. Okay. So this is how we do question 4, which is easy, not too bad, right? Because the zeros are nice. But if you look at question 5, the 0 is a little bit horrible. It's no longer 4 or -4 or 5, something nice. It's going to be 1 plus and 1 minus square root of 3. So these are the zeros given to you. So again, you have to write this in the factor form. So can someone tell me how you write 1 plus root 3 in a factor form? Or we start with x, don't forget. Anyone wants to give a try? Okay. Oh, pay attention then if you doesn't want. Okay, so what happened in this case class is that, remember last time when I said in order for you to write the factor form, you change your sign, right? Negative become positive. This is also the same thing, but you have to change your sign on both of them. So the 1 is a positive, it become minus. The root 3 is a positive, it become negative. So this is how we write this in the factor form, is you change all the sign from plus to minus, minus to plus. So can someone tell me what is the factor form for 1 minus root 3?
X minus 1 plus 3. Plus square root 3.
Very good. This is the so make sure you guys know that, because again, these kind of questions will be asked in your first test. So these are pretty much questions you see in my first test. So make sure you guys know this. And then now you need to FOIL it. Now foiling x plus 4 and x plus 5 is easy. You guys can just do it very quick, right? And foiling this is a little bit more work. How many terms you get when you FOIL this fellow is, you see there are 3 terms here, right? There are 3 terms here and there are 3 terms here. So 3 times 3 is what?
9.
You got 9. So when you FOIL this, you should end up with 9 terms before you combine, that. Okay, so let's FOIL it. And how do you FOIL it? You take the first one and you kind of distribute to all that. So take x, multiply with x, -1 and plus root 3. So you will get what? X squared followed by what? -x plus x root 3. So this is just for the x. Now you take the -1 and you do the same thing 3 times. So -1 times x is negative x. -1 with -1 is +1. -1 with root 3 is negative. And the last thing we're gonna do here is we take the negative root 3 and you do the same thing to all three of them. So negative root 3 times x is negative x root 3. And then negative root 3 times -1 is positive root 3. And negative times positive is negative. Root 3 times root 3 is square root of 9, which is the perfect square of 3. So if you count this, you should have 9 terms. You guys all right?
Yep.
And now you combine like terms. So x squared is by itself, you cannot combine it. How many x terms do we have? This fellow and this fellow, right? So we get -2x. What happens to the x root 3? It's being canceled out. Okay. 1 minus 3, this is 1. And -3, 1 minus 3 is -2. And what happens to your root 3? One of them is minus, one of them is plus. What happens? It's
Cancel out.
So you notice that when I give zeros, look at your polynomial functions. Do you see any square root in there? Do you see any square root in there? No, right? So my question to you is, every time when you FOIL something like this out, do you get square root in your final answer? The answer is no. You will never get square root. That means all the square root that you FOIL out is all been what? Cancel out. Is that always like that? The answer is yes, it's always like that. If you find out that your square root did not cancel out like what we did here, something is wrong with your factor. That means double check with your factor, or something maybe you FOIL wrongly. So what I want to point out to you is, this is very important. If you FOIL this one out, if you still cannot cancel with the roots and everything like what we have here, check back your work. That means something is wrong. If you get nice, no root like what we have in the final answer here, means you're doing the right way. You guys all right? Questions? Questions for me? Okay. So that is the hint. So when you guys do my tests, if I ask you question 4, question 5 with this, your answer should be really, really nice. So no square root off. Okay. This time I give you the 0 and the degree. You have give me the polynomial. Now, same thing like last time is you write your zeros into what? Into factor, right? So can someone tell me how you write question 6 in a factor form? This will be x, the 0 is 4. So what is the factor form in this case?
X minus 4.
Now, if you look at this one only have 1, this is only have power 1, right? But the degree is 1. But this question wants us to have a degree of 2. So if I just give you 1, 0, how can you write this in 2 powers, degree of 2? You will see again, class, when you do your homework, make sure you look at today's videos, because you'll see this. It's very easy. You just square it. Let me repeat. If you have only 1, 0, but the question wants you to write this in the power 2, you just square the factor. Okay. So this, when you FOIL it, you will get power 2. Can someone tell me what is the answer in question 6? What's the FOIL of that for them? Anyone foiling?
X squared minus 8x plus 16.
Yep, very good. And don't forget what in the front. The f of x.
Function.
F of X.
Yep. So this is your answer in this case. Okay. Question number 7. Can you also write this in the factor form? How many zeros is given in question 7?
3.
3.
3. So can you write that in a factor form?
X plus 2, X minus 4, X minus 7.
Yep. Now, what is the power when you only give, if I give you 3 zeros, your degree is only 3, right? Because you got 3 zeros. But this question wants us to have a degree of what?
4.
4. So it's like something like what we did. If I only give you 1, you just need to do what with the square, right? So what happens in here is you just need to pick one of this 0 and you just need to put a square on it. So if you put a square on it, then you do a power, then your degree will be power 4. So which one you want me to put a square on? Don't
The
put all.
first.
Okay, the first one. So you can do the first one, or you can do the middle one, or you can do the last one, doesn't matter, but don't do all 3. You can just do one. So same thing happens, like what we did in question 6. Can you void this follow-up for me? And then also void the last 2 out. There's a bit more work here in question 7. So x plus 2 squared give us x squared plus 2 times 2 times x, 4x, plus 4, because 2 squared is 4. And this one, you need to void it. That last two, you will get x squared. This is easier. Minus 4, negative 4 minus 7 is 11x. But negative 4 times negative 7 is positive 28. So this is the void. And you're not done yet, because what you need to void one more time here. So once you finish voiding this and that, you have to finalize voiding this. And don't forget, when you void this, your degree your power will be power 4. So go ahead, and I want everyone here, you guys, please void this one out. This is very important. Again, if you doesn't know how to void like this kind of work, you probably lose a lot of points in your first test. Go ahead and void it out. Again, this is 3 terms. This is 3 terms. When you void this, you should get 9 terms. Then when you combine like term, it's more. Anyone? X to the power of 4. X squared times negative 11 is negative 11x cubed. X squared times 28, this is 28x. So we do the x squared first. Next, we do the 4x. What's 4x times x squared? This is 4x cubed. So I'm going to put right underneath here because they're all in x cubed. 4x times this one. This is negative. Oh, I forgot the square on this fellow. It's 28x squared. 4x times negative 11 is negative 44x squared. So that's why this is under here. 4x times 28. Anyone has a calculator? What is 4 times 28?
112.
112. Okay, thank you. And then the last one is you take the 4 and do the same thing. So 4x squared minus 44x, because you get negative 11. And 4 times 28, anyone? Calculators. 100 and something. 104. 2? 102?
112, I think.
112 again? Okay. Use your calculator. And then you just add them up. So this will be x4. This will be positive here. So this will be negative 7x cubed. Again, calculate if you need to. 32, take away 44. Anyone? How many x squared we have? Last one, 1, 2 for sure. You guys know how to do this, all right? So 12, right? This is 12. And this one is how many? Hello? 68? Something like that,
Yeah, 68.
right? This is correct, right?
Yes, that's what I got.
And what you have in front, what you need to put up front here. I don't want to take half a point in your test. Half of X. Yep, don't forget. Don't have this, I'll take half a point. So this is your answer for question 7. It's a bit more work because it's a lot of foiling and everything. But make sure you guys know how to do this. It's not that difficult. It's just a lot of tedious work, you know. Foiling is a big stuff in this case. Okay. Questions with this one? Anyone have any questions? Because you, as I told you, right, you will get this in your first test. So make sure you guys know how to do it. And also in your first test, you will get this 8 and 9. So these 2 questions is what I want you to really, really pay attention here, because this is also coming up in your test, and this worth like 10 to 12 points. Because if you see A, B, C, D, that means, you know, A has, you know, there are points given here. So so I really want you guys to really pay attention on this question 8, because I don't want you to miss 10 or 12 points here. That is a big, you know, big chunk of points that. So how do we do like question 8 here? The first part A is asking us to do what we call as apply the leading coefficient test. So what is the leading coefficient test? You guys ask me. The leading coefficient test is this one. Either you go down or you go up on the left, or you go down or you go up on the right. So this is what we call as a leading coefficient test. So how do we figure out on this is figure out what is your power here. Can someone tell me what power in this case? Even or odd?
Odd.
This is odd because of this fellow. And is a leading coefficient positive or negative?
Negative.
This is not
Positive,
upfront.
sorry.
So it's positive. So leading coefficient is positive. So which one is it? Is it going to be A, down, up, or up, up, or up, down, or down, down? That you have odds and your leading coefficient is positive. So what is this? It's going to be down on is this one, right?
Yep.
Down on the left. So that means this will be go down on the left, and on the right it goes what? It goes up. So this is, you can do this in my task because I understand what you're doing. You go down on the left and you go right on the up on the right. But in your online homework, they say negative infinity on the left and positive infinity on the right. So down means negative infinity, and then up means positive infinity. So they use the infinity symbols, which is the same thing as up and down. Okay, so this is the first thing you need to do on part A, which is asking us about applying the leading. This is called applying leading coefficient. Part B is asking us to find the real zero. So how do you find the real zero? Is you have to factor this. Does anyone know how to factor x cubed minus 2x squared? Anyone know how to factor this? What can you factor here? That's a common factor. What can you factor out here?
X.
Square. And you will get x minus 2. So this question wants us to find the zeros. Zeros is the same thing as solution or x-intercept. So you just need to take this equals to what? Equals to 0. So can someone tell me what is the answer you get here, the zeros? X is what? Anyone?
0 and positive 2.
Yep, so this is how we find the zero. So if a question in this case is asking us to find the real zeros, this is the find the real zeros. Okay, Now, part C, I don't ask you for the solution. I will don't do that. So part C, I will ask you for what is the multiplicity. This is in your test. That's why I'm doing this with every one of you. So make sure you guys. So what is multiplicity is the k. Remember last time when you have a factor, whatever power you get, that is your multiplicity. So if you look at this x squared, you get 0. So this has what multiplicity? This has even multiplicity. And the reason why this is an even multiplicity is because this power is even. That's how you figure out. It's very easy. You look, once you finish factor, you look at the power. If you have 2, 4, 6, 8, the multiplicity is even. And when you have even, it's telling you that you have to touch. You will touch on the graph. That means your parabola is a parabola. Either open upward or open downwards. Can someone tell me what is the multiplicity of x equals to 2? Is that even or odd?
Even.
And why you say it's even?
Because it's
What's the power you see?
there's no problem.
No power means what power is?
It's power 1.
This is power 1. You're correct. So if this is power 1, means this is what? Even or not?
Odd.
This
Odd.
is odd. Yes, this is odd. So that means that it will cross on the graph. So make sure you guys know that in order for us to figure the multiplicity is even or not, look at your powers. If your power is no power, which is 1, or 3 or 5 is odd. 2, 4, 6 is even. Then part D, they will ask you for turning points. How many turning points can you have in this case? And what is the formula to figure out turning points? The formula is n minus 1. And n in this case is your degree, your power. So what is your, how many turning points do we have in this case?
1,
No, what's the power here?
2.
No.
Oh, 3. Sorry. So then
3.
that's
Your
2.
power is 3 here. So it's 3 minus 1. So it's actually, it has 2 turning points. Okay. And how the E will be the graph. So how do we graph this? Definitely, I give you graph papers. So first thing is you apply the ABC here. So A, you know, it goes down on the left and it goes right up on the right. This is the, we call it as the end behavior or the leading coefficient test. And then B, you tell me it is 0 is your, so 0 is right here. 0, 0 is your x-intercept or your zeros. On 2 is your zeros. Okay. And then you told me this 0 is even. So you touch it. So at 0, it touches. So my question to you is this going to open upward or you think this is going to open down? Because it's even means it's parabola. Upward or downward parabola? And why you say that? Anyone? Going up or going down? You guys are quiet.
I think it's going to go down
Why is going to go down?
because then it would match with the entire graph.
Because on part A, you told me that on the left side is going down, right? So that
Yeah.
means this side will be going down like this. Because
Yeah.
you're telling me this is heading down. So that means if you go up, then it's not the same as A, because A told me you go down on the left side. So what happened is that, so at one point, this graph will go down and then it will turn back up and you will 2, because 2 you say is odd. So it will cross right here and then you go back up. So your graph will look something like this. And then you turn around here. And how many turning points you have? You got 2, 1 turning points here and the other 1 turning points. And students will ask me, how low is this, the one on here turning points? You do not need to know how low it goes because you will learn that in your calculus 1, which is the next class. So you just need to know this has a turning point somewhere around here. And then after it goes up. So this is what your graph looks like for question 8. And this worth 10 to 12 points in your test. I'm not kidding you, the first test. So make sure you guys pay attention on this. And we do another one, which is the question 9. I'm going to use X and not use T first. So in your test, if you don't like me here, you don't like use T, you don't like to use T, you want to use X, be my guest. I'm not picky with it. So now, if you look at question 9, is that been factored for you? Is question 9 been factored for you? Do you need to factor it like what we did in number 8? So question 9 is already been factored for you. So you do not need to do factor here. So my question in this case is the same thing. What is the leading coefficient test? So can someone tell me what is your power is and what is your leading coefficient? And if you doesn't know this, you better pay attention. So anyone know what is your degree here? 1,
4.
2, 3, 4. How do you get 4, Gamma?
Because it's factored and you have 2 squares.
So these 2, you add them up. So 2 plus 2 become 4. Because this is. Now what happens if I slot an X on here? Because this one doesn't have X, right? What happens if I put an X in here? So what degree is it if I put an X in here?
5.
That'll be 5 because this is power 1. So 1 plus 2 is 5. Okay. Just want to point out to you guys that don't forget to add your powers. If you want to know what degree is, you just add your powers. Leading coefficient is your leading coefficient positive, which is even, right? 4 is even. Can someone tell me what is your leading coefficient here? Positive or negative? And why you say that? If you say positive, why? Which tell you is positive? Which tell you that? Anyone going to give a try?
Negative.
Why is negative? Which is correct.
Negative 1/4.
Yeah, because of negative 1/4. You're correct. So in order for us to figure out what is the leading coefficient, you just look at the front. If that's a negative, it's negative. If it's a positive, it's positive. So by looking at the leading coefficient chart that I will show you right here, can you tell me which one is the leading coefficient? Is that up, down, up, 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 down, up, or down, down? Which one is the correct leading coefficient test in this case?
Down, down.
Yep, this will be down, down, which is this one, because you have even and your leading stack. So that means you both are going down, down. Okay. Now in part B, they want us to find the zeros. So how do you find the zeros in this case? This is factor, so you just set all these equals to 0 and solve for x. Now is the negative 1/4 play an important role to find the zeros? Is this important for zeros?
No.
You're correct. That is not important. But what happens if I put an X in here? Is this important to find zeros?
Yes.
Yes, this will give us 0. If you have an X in there, that will give you 0. But what happens for this case, since we don't have an X, this is no useless. So the 0 in this case is what? 1 is 2. And what's this one? -2. That will be your zeros, right? And can someone tell me what is the multiplicity here? So for 2, the multiplicity is even or odd?
Even.
Yeah.
Why this is even?
Square root on the x minus 2.
Because of the
I mean the square, not square.
square. Yep, up here, right? How about this -2? Even or odd?
Even.
This is also even because of what?
The
The
square.
square. And since they are even means your graph has to be touch. Okay, so make sure you know what it is. Turning points, I use short form to use TP, turning points. The formula to find turning points is n minus 1. So what is your turning point in this case? Don't forget, we got degree is 4, n is 4 here. So how many turning points? There will be 3 turning points, right? Because it's now we need to graph. So the first thing you're telling me, this both goes down. So I just put down, goes down. 2 and negative 2. So negative 2 is here and 2 is here. This is your x-intercept or your zeros here. And it's touches. Touches mean parabola. So can someone tell me, if you look at the negative 2, is this going up or is this going up and down?
Down.
And what tells is open down? Part A. Yep. So this is going like this. So this one turning point, and at one point, this fellow will turn back up. And then what happens to 2? It will also turn back down like that. So you got 3 turning point, 1, 2, and 3, and both of these are going down. And how low this turning point in the middle, again, calculus 1, you will learn that. So right now, you just need to know that there are the turning points is on this x-intercept. So this is your graph for question 9. Can you guys do this in my test in 2 weeks? I think you have a first test on the 2nd, 2 weeks from today. 2 weeks, I think. 2 weeks on a Wednesday. Yeah. Questions for me? Anyone? Okay, I want attendance. So make sure to put in the chat room that you're present. So it's the attendance time. Please, yep, you know what to do. All right, so this is 3.2. So we're going to talk about 3.3. Okay, so this is syntactic division. So this is very important also. You guys know how to do attendance, right? So make sure you do attendance. Where's my, okay, there you go. Attendance part, yep. So 3.3 is talking about how we solve polynomial equations. So the first thing you need to know here is how to perform syntactic division. So this is 3.3. So there are 2 ways for us to divide polynomial. One is using the long division, and one is using the syntactic division. The only thing I want to point out to you here is the long, we don't use long division in this class because it's long. So we're going to use syntactic division. So how do we perform syntactic division is you put the zeros in here. And usually you find the zeros in the denominator. And then you put all your coefficient inside here. Okay. And I will show it to you what it looks like. I'll give you an example. So let's do an example here. There you go. So question number 1. So I'm doing syntactic division here. So you guys pay attention, and then you're going to probably do the next one. Question number 1 is doing 180x minus x4 divided by x over minus 6. So in order for us to figure out what number to put in here is you take your denominator and make it equal to 0. So x minus 6 equals to 0. What is x going to be in this case? 6. Okay. And then the next thing is you look at this, the top one, you have to put your coefficient here. Now, when you put your coefficient here, this has to be in a standard form. Standard form means from the highest power to the lowest power. And if there is a missing term, any missing term, you have to include 0 on it as a placeholder. So can someone tell me how you write this into a standard form? 180x minus x4. So it should be negative x4. Do we have x3 here?
No.
We don't, so you have to put a 0 x3. Do we have any x squared here? No, you also have to put 0 x squared. We have x, 180x. Do we have any constant term, means number term? That one is also no, so you have to put 0. So that means that in order for you to write the coefficient here, you got -1, you got 0, you got 0, you got 180 for x term, and you got 0 for the constant term. You guys all right here? So when you guys do the syntactic division, what you need to do here is this -1, you bring it down. Okay, pay attention. And you multiply. In order for you to find what is the next number to put in, you multiply this number 6 with the -1, you put it -6. And you always add these two up together. So 0 minus plus -6, you get -6. Repeat. Take the 6 times with -6, that is -36. Add them up. 0 plus -36 is -36. Multiply them up together. I need my calculator. So what is 6 times -36? 6 times 36. This will be -216. And you have to add this up. So 180 minus 216. So that will be -36. And then multiply it with 6 again. This is -216. And you add with 0, you get -2. So this is how you perform what we call as syntactic division. So don't forget, you need to have a placeholder zeros. If you don't have a term, you have to write it in the standard form. And you always bring down the first one, and then you multiply and add, keep on doing. So once you get into this, this is your answer. The one underneath the red line here is your answer. The last one is your remainder. Okay, so when you divide, you always have a remainder. So if your remainder is 0, then x minus 6 will be a factor. Let me repeat again. This is an important theorem. If this remainder you add up to become 0, that means x minus 6 that you use here is a factor. Since if you do this remainder is not a 0, then x minus 6 is not a factor. So not a factor means that it won't intercept on your x-intercept. Now, the whatever left over here that is not on the last number is gonna be your quotient. Quotient means what you left. So when you divide something, remember when you divide something, you got something here, and then you got a remainder here, right? So this is what we call as your quotient. Okay, so whatever you got. So this quotient is a 1 power less than you divide. So this one is a power 4, right? Because you start with power 4. So this will be a power 3, then followed by power 2, power 1, and then the constant. So this answer will be negative x cubed, or negative 1x cubed, minus 6x squared, minus 36x, minus 36. And then the remainder is minus 216 over by x minus 6, because x minus 6 is what we divide with. So this is your answer for this using your syntactic division. And if you want to do long division, it's going to be 30 minutes longer. So that's why I want you guys to know how to use your syntactic division to do this. And again, if you doesn't know how to use syntactic division, say goodbye to half of the first test score, because the first test, a lot of them is based on syntactic division, like what I just did here. So if you do not know how to do syntactic division, it's really, really bad. Okay. So I want you guys to try to do this one now. it's going to be 3x cubed minus 4x squared plus 5 divided by x minus 3/2. So I want you guys to do question 2 using syntactic division. This is, again, very important. Go ahead and try to do question 2. So make sure you know what to put in here. And then make sure you write this in a standard form. And if you're missing any terms, you need to put 0. And it has a domino effect, means if you make a mistake on the beginning, the rest is all going to be wrong. So be careful with it. So can someone tell me what number should we put inside this box here? And how you find it? Anyone? Last time I put x 6 here because it comes from x minus 6.
3 halves.
Hmm?
We put 3 halves in that.
3/2. Yep. Oh, if I want, I put 1.5, which is the same thing as what? 3/2.
Yeah.
1.5 will be easier when you do the division. All right. Anyone? You guys good? Okay, next, what number should we put next to this? 3, because it comes from the 3x cubed. What number are you going to put next to the 3?
-4.
Because it comes from 4x squared. What are you going to put next to the -4?
5.
No. 0. If you put 5, be careful. Why 0?
Because there's no.
There's no x. Don't forget, if you don't have any x missing term, you have to put 0. And what's the last number you put in here? 5. So I just want to point out to you guys, if you see power 4, how many numbers you should have if you see power 4? You have 5 numbers. This one is a power 3, right? So what numbers, how many numbers you should have in here? You should have 4. So make sure you guys know that when you see power 3, you should have 4 numbers. If you see power 4, you should have 5. And if you don't have those, means you're missing the zeros. Okay. So anyone know what to do first thing first once you got this set up? Correct. What you do with the 3? You drop it, right? Can someone tell me what's to do next?
Multiply by 1.5.
Multiply by 1/5 or 3/2, 1/5, 1.5. So what's 3 times 1.5? 1.5.
4.5.
4.5. And what you always do with these two numbers? You always add them, not subtract, because you guys know when you divide, you always subtract those numbers, right? This one is add, special. So what you get when you take -4 plus 4.5? 0.5. And you repeat, right? What is 0.5 times with 1.5? Use your calculator, don't ask me.
0.75.
0.75, and you add it with 0, you get what?
0.75.
0.75, and then multiply this again with 1.5.
1.125.
1.125, and add this again. 6.125, right? Is that correct? Okay. And what is this 6.125 we call that?
The remainder.
Your remainder. And don't forget, this one is an x cubed, right? So can you tell me what is your answer in this case? 3.
X to the third.
Not third. Remember the
Squared.
Very tight.
square, right? Because if you have 4, it minus 1, right? 1 down. So plus what?
0.5x.
0.5x plus
0.75.
0.75 plus 6.125 divided by what? X minus 3
It's
half.
minus 3 3/3.
And why the 3 next minus 3 half came from the question. Okay. You guys all right here? So this is the main attraction on 3.3. So if you do not, this is again, I want to tell you, if you do not know how to do this, make sure you probably need to brush it up. Because this is self-learn. I told you, right? We don't have class on Wednesday. So you have to self-learn this because that is very important. Okay. So the next thing we're going to talk about here is how you write this in the what we call as a dividing function using the division algorithm. So so when you do the division algorithms, you can always write a function in the form of x minus k. X minus k is what the factor that you divide. Like this is x minus 6, x minus 3 half. That is the x minus k. Qx is the quotient. Remember last time the quotient is 3x squared plus something. That is the quotient at 0.5x something else. And the r is the remainder. So you can always write that in this form by doing what we call as syntactic division. So like question number 3, you can actually syntactic division this. So last time, remember, you have to add, you have to solve for x here to make it 0, like 6 and 3 half. So in this case, if I give you just k equals to -2, this is not in the factor form, this is a 0 form, then this number will be a -2. And then the same thing happens here. You just rewrite this in the your coefficient. So 1 here for x cubed, -5 is for x squared, -11 for x, and 8 is for the constant. And you don't have to put 0 here because there is no missing terms. And as usual, just drop the 1. Now you guys do it for me. What you guys do? Go ahead. You guys know how to do this. And I don't see you in 10 days. So when I come back on next Wednesday, I'll just give you a pop quiz. So it's like, all right, I want you guys to do syntactic division on this. In less than 5 minutes. So what number should we put in under -5?
-7.
-7. So you get -2 here, right? Just put it down here. And then what next? 14, right? Negative times negative is positive 14. And what happens when you add these two up?
13. 3.
3. And multiply this, you get what? -6. And you add up with a 2, right? And this is your remainder. Can someone tell me what is your quotient in this case? X squared minus 7x plus 3. You guys okay here? Now, last time you add 2 over by, x minus 2, like what we just, x plus 2. Because this is a little bit different. So in this case, you want to write this in the division algorithm form. So what you do here is you put f of x equals to x minus k. So x minus k in this case is x plus 2. Because this is a -2 and this is your k. So don't forget, this is your k. So x minus k means 2 negative become positive. And then the one that you got over here is your qx. That is the reason we call it qx is because it's quotient. And then you just need to add your remainder 2 back there. So this is how you write this in the division algorithm form. Is you put the -2 become +2, and then you put the quotient in the middle, and then you plus it. So this is also another way for us to write this division algorithm, this function form instead of the one that you showed just now, the 2 over the remainder, some, the one, the very long one. So this is another way to do it. There is also another way for us to find the remainder. So one way is doing syntactic division. You do all this work and then you find, oh, 2 is a remainder. Another way for you to figure out remainder is this. This is also a theorem. Is if you just replace this negative to the k into the function. So if you find what is f of negative 2, because your k is negative 2, so you plug it into this x here. So you got negative 2 cubed minus 5 times negative 2 squared minus 11 times negative 2 plus 8. I can tell you that your answer here is gonna be 2, which is exactly the same as your remainder. And it's always worked that way. So how many ways can you find a remainder? 2 ways. One way is doing syntactic, or then the last number here is your remainder. Another way is you just substitute this, the 0, the negative 2, into your x, into the original equation, and solve and simplify or evaluate it. And you will get yourself a number, let's say 2, and that is your remainder. Now, which way I suggest you to learn or to do, because 2 ways, right? I will suggest you to do the syntactic division. Don't do this way. I mean, you can, but this is another way to do it. But I will strongly suggest, because in the next section, we will be concentrate on doing syntactic division, then doing like what I just showed you. Okay. Now, we did fraction 3/2 before. We did negative number. Can syntactic division do square root? And question 4, you see square root, right? The answer is yes. So it can be in square root form. It can be even on complex. So this is the last question I'll do here. So so what I'm talking about here is, class, no matter what is your 0 is, it can be square root, it can be nice whole number, it can be fraction, it can be complex number, you can still perform syntactic division. So this is 1, this is 3. I'm going to spread a little bit apart on these numbers, negative 2 and negative 14. So I'm going to show it to you guys what happens when you have a square root number. So you drop the 1, and then 1 times root 2 is root 2. Now, when you add this, they are not like terms. It's not 5 or root 5. This is actually 3 plus root 2. Now, this is the difficult part, is where now you need to take this times. So what is square root of 2 times with 3 plus root 2? Because you need to multiply this. So when you distribute this, you will get 3 root 2 plus 2, because root 2 times root 2 is root 4 is 2. So this one you will get 3 root 2 plus 2. And when you add this 2 and this 2 will cancel out because it's 0. So what you left in this case is 3 root 2. And then you need to multiply this 3 root 2 with root 2, because you need to multiply this with the square of 2. So this is actually 3 times root 4, which is 3 times 2. So you get 6. So don't forget that root 2 times root 2 is root 4. 4 is a perfect square of 2. So 3 times 2 is 6. And when you add this will give me negative 8. So this will be your remainder. And this will be your quotient. So if I want to write this in a division algorithm, it will be fx equals to x minus root 2, because the square of 2 is your k. And then now we got this quotient piece here, x squared plus 3 plus root 2x plus 3 root 2. This is all inside the quotient, this little parenthesis. And then minus 8 is a remainder. So this is your your answer for question number 4. And then if you plug √2 inside this x cube, so if you put √2 inside there, you will, if you plug f of √2 into your x, you will get -8, because that is where your remainder will be. So so this is how we do question 3 and question 4. So I don't have time to finish this, so I would recommend you guys to watch the videos. I do have notes here, my notes here. So these kind of questions are pretty important, especially like 8 and 9 here. So please watch the videos. I send it to you. These are very, very important homework sections here. So that's it for today's work. Does anyone have any questions for me? So you do have 3 homework due on Wednesday, 2, 6, 2, 7, 3, 1, and then you got 2 on the following Wednesday, 3, 2, and 3, 3. We don't meet on Wednesday and we don't meet on Monday. So the next time I see you is 10 days, around 9, 10 days from today, which is the following Wednesday. So if you do have questions, do stay back and ask me. If you do not have questions, you may go. Do not forget to put attendance present in your, yep, you guys did it, good. Anyone have any questions for me?